Hello everyone and welcome to all of you to our channel Schrodinger's Cat. And basically this is Devabrata here. So in our previous lecture we had discussed the rotational motion from class 11, and today we'll discuss the optics, the important topic from class 12. And I just confess one thing for your exam point of view. Today we just discuss here the chapter summary in a nutshell and two problem in NEET, JEE Main and Advanced, and after we just got time we covered the elaborate theory. So let's get started. Today we'll cover the ray optics and optical instrument, reflection of light, refraction, tear and prism, lenses, optical instruments, wave optics, Huygens principle and Doppler's effect of light, interference and the Young's double slit experiment, diffraction and the polarization, and the total number of questions coming in the NEET exam 3 or 4, and the JEE Main 4 or 5, and the JEE Advanced 4 questions. So let's get started for a chapter summary. So basically we just draw a line for your better clarifications. So first of all is that the reflection of light, relation between U, V and the R for the mirror, that 1 by U is equal to 1 by V, 1 by U plus 1 by V is equal to 2 by R. F is equal to R by 2. So we just write that the 1 by U plus 1 by V is equal to 1 by F. U is the object distance, V be the image distance, F be the focal length. So lateral magnification, that the height of image I and the height of object I by U is written as V by U. Next one, that the ray diagram for concave mirror. So first one, the ray diagram, that this is a concave mirror, this type of. Here this object, so ray with these directions and come back in that. This is the O and this is object F. Next one, this type of so it would follow back this direction. So here the image would be produced, that the I, here the distance is x, and the y, this one, this is the C. So between pole and the focus, the position of the object between the pole and the focus and position of image would be the behind of mirror, and the nature would be the virtual and the effect. Virtual and erect, and it should be magnified. So nature would be the virtual and erect. So next one, at focus. So at focus it would become just focus point here. This is the object. So this direction and come back this focus, that next one, this and come back in this direction. So it is C and this is focus. Basically here it would be the F. So here at focus the nature would be the real and the inverted. Real inverted. Next one, between focus and center of curvature. So concave mirror. So center of curvature and the focus. So here it would be F and C. So pass just these directions and come back to focus. This one and another one. This and follow back in these directions. So here F and this is P and image would be this one. This would be the image, this would be the object. So here should be the nature of the image, real and inverted. Next one, at center of curvature. So in center of curvature, that the ray diagram, this one, the center of curvature, this is the object C, O, this is the focus F. So light this direction and come back passing through the focus, and another one, this focus and this direction. So I would be this one, this is the P. So here the nature would be should real and inverted. Next one, between center of curvature and the infinity. So the center of curvature and the infinity. So this is the F, C, this is the object, this direction and follow back in focus. Next one, with this C and reflect back in this direction. So I would be this one, this is the I and this is the O. Here would be always the real and inverted. And next one, this is the nature, real and inverted, but the position of the image would be between focus and center of curvature. And next one, an infinity. So the ray diagram would be at infinity type, that this is the F and this C. So light come infinity to passing through focus and follow back in this direction, and another one, the center of curvature, this direction and follow back in the same path. So I would be this one, this would be the I, this is the P, this would be the image. So we just cover here the reflection of light and the mirror. That second one we just discuss the lenses. So first of all, the lens refraction at spherical surfaces, relation between U, V and the R, that mu2 divided by V minus mu1 divided by U is equal to mu2 minus mu1 divided by R, and the magnification M mu1 V divided by mu2 U here the condition that the mu2 is greater than mu1. I just not draw here the figure, you just imagine. And next one, the lens maker's formula and the lens formula. This is very important. The lens maker's formula, that the 1 by f is equal to mu minus 1 by r1 minus 1 by r2. This is called the lens maker's formula, and the lens formula 1 by v minus 1 by u equal to 1 by f. 1 by v minus 1 by u equal to 1 by f, and the magnification here m would be v by u, or this is written as the f minus v, the f minus v by f minus v by f, or it is written as the f by f plus u, and the power of the lens is written as p equal to 1 by f. And thin lenses in contact, next one, the thin lenses in contact, so this would become that the 1 by v minus 1 by u is equal to 1 by f1 plus 1 by f2, f1 plus 1 by f2, that would become 1 by f. Basically the equivalent focus, that 1 by f equivalent is equal to 1 by f1 plus 1 by f2, and the power would become P equal to equivalent power P1 plus P2. Next one, two thin lenses separate by distance. This is lens contact, and separate, this is separate in a distance. So 1 by f equal to 1 by f1 plus 1 by f2 minus d distance f1 f2, and the position of the equivalent lens, the position of the equivalent lens would be df divided by f1. So next one, position, size and nature of the image formed by the convex lens. I just draw one, that between infinity and 2f, that the position of the image, ray diagram, that here is a lens, the image, this is the f1, this is the 2f1, and the image O is in between infinity and 2f. This is the image. So you have to find, this is the object, and you have to find the image range. So light would go in these directions. So after one, here this is the f2 to f2, just pass. So this. Next one, that this one, light will pass, just this one. So and the image would form in between 2f. This would be the I. So image range would be between the f less than I image less than 2f. This is case 1. And here real inverted image with magnification m less than -1. Next one, that at 2f. So image O is in 2f. So lens, this is the f and this is 2f. So here would be the image I. Here would be the object, object O. This is f1 and f2. Just this direction and pass through the focus. Next one is in this one. So image would be in that I. So image would be at 2f also. Here the nature real inverted and the m equal to -1. That next one in f, this is very important, at focus. So this is a lens and this is f1 to f1 and another here this side f2 to f2. Object is in this option, that is at f1. So light this direction, just draw the ray here. So without ray you would be get 0. Without array in light you would be get 0. This is a proverb. So just pass this focus and the another one, this one. So here they meet that at infinity. So here the object O is in focus and the image would be at infinity. Here the magnification would be greater -1. So these are the lenses ray diagram, and we now just go ahead our next topic, that the refraction at plane surfaces. So refraction at plane surfaces, first of all is the Snell's law, says that sin I by sin R is equal to V1 by V2 is equal to mu2 by mu1 is equal to lambda1 by lambda2. This is the Snell's law. And refractive index ANB is equal to refractive index of NB by NA, and this ANB is refractive index of B, refractive index of B with respect to A. Or second one, that the property 1n2 into 2n3 into 3n1 is equal to 1, as 1n2 into 2n1 is equal to 1. So apply this, that air refractive index water and the water refractive index with gas, the gas refractive index of water of air is 1. So, or with respect to gas of water, refractive index is 1 by A refractive index water and the gas refractive index of air. Basically, the refractive index of gas with respect to water, that would become the ANZ divided by ANW. Similarly, the GNW is equal to ANW divided by AN gas, G for gas. The second one is the 1 by mu. Suppose medium 2 is air and an observer looks at an image from the medium, that mu is equal to real depth by apparent depth. Real depth divided by apparent depth. And the del t here would become del t 1 minus 1 by mu into t. Del t be the apparent shift. So apparent depth because of the liquid, this one, and the total shift of object due to a multiple slab. Suppose these are the multiple slabs here. So first one in the thickness T1, T2, T3, mu1, mu2 and the mu3. So in that case the total shift S1, S2 plus S3 would be the T1 1 by 1 minus mu plus T2 1 minus 1 by mu2, this is for the mu1, and last one the 3T 1 minus 1 by mu3 plus dot dot. So critical angle, next one, the critical angle that basically the mu2 is 1, mu1 is mu. So sine theta c by Snell's law at an sine 90 degree is equal to 1 by mu, or sine theta c would be 1 by mu, or theta c, the critical angle, would become sine inverse 1 by mu. So in a ray reflected through multiple medium, that mu1 sine theta 1 equal to mu2 sine theta 2 is equal to mu3 sine theta 3 equal to constant. Next one, image formed by slab, that y is equal to 1 minus mu m by mu into d. So next one, the prism, that in prism case, so here delta is the angle of deflection and A be the angle of prism. Suppose this triangle is the prism with angle A, B and this C. Light is in these directions, this and this. So here this is reflecting and this would be the delta. This is the I dash, R and the R dash. So here the angle of deviation delta would become I plus I dash minus A. Also R plus R dash equal to A. Minimum deviation just delta M for r equal to r dashed and I equal to I dashed, the refractive index would become mu equal to sin I by sin r. That would be the sin a plus del m by 2 by sin a by 2. For a thin prism that del m would become mu minus 1 into a. This is for the thin prism, and condition for no emerges. Condition for no emerges that a greater than 2 theta c. So mu would greater than the cosec a by 2. And next one, the radius of surface seen by a river on water surface at depth h would become r equal to a is by root over n square minus 1, or r equal to tan h tan ic. And our next discussion, the interference of light. So in the interference of light, so first one, that the resultant intensity wave of y equal to a1 sin omega t and the y2 a2 sin omega t plus phi, the resultant y equal to sum of y1 plus y2 is equal to r sin omega t plus theta, where r square a1 square plus a2 square plus 2 a1 a2 cos phi, and the intensity of resultant that the I1 plus the I2 plus 2 root over I1 I2 cos phi. Basically the I is proportional to a square. Next one, constructive interference and the destructive interference. So first one, the constructive. For the constructive interference, when cos phi is plus 1, that implies the phase difference del phi 2m pi, even multiple of pi, and the path difference here del x, you just know lambda by twice pi del phi would become the m lambda. So here the I max would become the I1 plus I2 plus 2 root I1 I2. This is basically root I1 plus root I2 whole square, or k a1 plus a2 whole square. Next one, for the destructive for the destructive interference, for cos phi minus 1, or phi would become odd multiple of pi. So the path difference del x 2m minus 1 into lambda by 2. So here I mean that would become the I1 plus I2 minus 2 root over I1 I2. This would become that root over I1 minus root over I2 whole square. This would become the k a1 minus a2 whole square. Next one, that the Young's experiment. So in Young's experiment, that distance of m bright fringe x distance, that m d lambda by d, and for dark fringe that the x d by d m minus half into lambda. this is the maxima x, and here the x, this is the maxima, and the minima x is equal to m minus half d lambda by d. This is for the minimum. So fringe width, putting m equal to 1, that the fringe width w is equal to d lambda divided by d, and the angular fringe width would be theta lambda by d. This is the fringe width. And this is the angular fringe width. Next one, inserting a slab between the incident wave. So here the path difference would become, in that case, x naught is equal to d by d n minus 1 into t be the thickness of the slab. And the next one, light wave traveling in a medium of refractive index mu. So for that case, the wave equation y equal to a naught sine omega t minus x by c. So it, for index mu, it would become y equal to a naught sine omega t minus mu x by c. Now, effect of wavelength, that we just know for path difference del x, the phase difference would become mu omega by c del x. Now, effect of wavelength would become lambda n equal to lambda naught by mu. Lambda n be the wavelength of light medium and mu be the refractive index. Last one, the Malus law for polarization, that the I equal to I naught cos square theta, where I naught is intensity when E vector is parallel to transmission axis. Next one, that the dispersion, so the dispersion that, just a minute. So I think that first of all, the phenomena of separation of different constituent colors of light while passing through a transparent medium is called the dispersion of light. So here the angular dispersion, the angular dispersion means delta V minus delta R is equal to mu V violet and mu R red into A. Average dispersion, that the delta Y yellow, mu I minus 1 into A, and the dispersive power of medium, dispersive power written as omega, that del V minus del R divided by delta Y is equal to mu V minus mu R divided by mu Y minus 1. Next one, the dispersion without deviation and deviation without dispersion. So in this format, the net angular dispersion would be the net angular dispersion delta V minus delta R is equal to the mu Y minus 1 omega A minus mu Y dash minus 1 omega dash A dash, and the average deviation, that the delta Y is equal to mu Y minus 1 into A minus mu dash Y minus 1 into A dash. Next, dispersion without average deviation. So dispersion without average deviation means delta y is equal to 0. Now the del violet minus del red is equal to mu y minus 1 into a omega minus omega dashed. Basically here the condition mu y minus 1 into a is equal to mu dashed y minus 1 into a dashed. Now average dispersion without average deviation without dispersion. So here the delta violet minus delta r would be 0. So here the delta would mu I minus 1 into a 1 minus omega by omega dashed. Next one, the a harmonic combination of two lengths. This is important for JEE, that omega by f plus omega dashed by f dashed is equal to 0. This is the achromatic combination. Achromatic combinations. Now, the optical instrument. Next one, the optical instrument, that magnifying power. So M would be 1 plus d by f, distinct vision, and for normal vision d by f. Next one, for distinct vision the M would be v naught by u naught 1 plus d by fe. This is basically the ME into ME. MO, magnification of object, and magnification of the image. Basically here O means object and image means the eyepiece. Next one, for the normal vision, this would be the v naught divided by u naught d plus fe. So the graph would like be, this is the M and here the L, straight line passing through origin. Next one, that the astronomical telescope. For the telescope, image at an infinity, so M magnification would be f naught by fe, because total L equal to f naught plus fe. Total length is basically telescope focus f naught plus fe, and the distinct vision, so M would be the f naught and the fe 1 plus fe by d, and the L would become the f naught plus d fe divided by d plus fe. L be the length of the telescope tube. Next one, the shift of position of eyepiece, the S would become the fe square divided by d plus fe. Next one, the Galilean telescope. Next one, the Galilean telescope, where the normal vision of M, that f naught by fe, and for the distinct vision, that the f naught by fe 1 minus fe by d. The total L would be that the f naught plus fe equal to v naught minus ue. This is very important. The resolving power Rp for microscope resolving power R 2 mu sin theta divided by lambda, and for the telescope the R would be A by 1.22 lambda where A would be the diameter. Next one, the photometry, that the solid angle d omega is equal to a cos theta by r square, and the luminous intensity I would be del F, that is the luminous flux, and the del W, and the total flux F would be 4 pi I, and the illumination flux density would be E del F by del A. Basically, the 1/4 is equal to 10 to the power 4 lakhs. The principle of photometry is IT by I1 plus I2 is equal to d1 square by d2. Lambert's cosine law, last one. Lambert's cosine law, this is the last, E equal to I cos theta divided by r square. I cos theta divided by r square. So now go at our last topic, is that basically the Doppler's effect. This is the last, that beats and the Doppler's effect. So first of one, that apparent frequency is n dashed, actual frequency is n, speed of sound source is Vs, speed of observer is equal to V naught, and the speed of sound is V. So first one, this is the source and observer moving in this direction with the Vs. So here the n dash would become n V by V minus Vs. Case number 1. Second one, the source and this is observer moving in this, and here one thing, that n dash is greater than n. So here the n dash would become n V by V plus Vs. Here n dash less than n. Next one, observer is moving towards the source, that this is source and the observer, and observer is moving VO. Here Vs is moving. So in that case, the n dash would become n V minus V naught divided by V. Here the n dash is greater than n. Next one, that both are moving. Next one is basically the observer is moving, both are moving case. So S source and the observer, source is moving with velocity Vs and observer is V naught. Here the n dash would become n V minus V naught divided by V minus Vs. And here two case, this is the approaching to our observer, and for case 2 approaching the source, that n dot would become V plus V naught divided by V plus Vs. When both are moving away with each other, that n dash is equal to n V plus minus V naught divided by V plus minus Vs. This is for the positive, negative would become source and the observer is moving other direction, and for positive in the same direction, this is source and this is observer. So last one, the beat frequency, beats. So When frequency of two sound is N1 and the N2, time between two successive maxima, that the time T 1 by N1 minus N2 in second, and the bit means bit per second or frequency bit. The frequency bits is equal to that N1 minus N2. This is the difference in frequency of the sound source. So it just covers the chapter summary of reflection, refraction, lenses, interference, dispersion, and the polarization. Next one, we switched our lecture into the problem discussion session. So this problem is coming in 23 JEE Main questions. A ray of light is incident at a glass water interference at angle I. It emerges finally parallel to the surface of water. To just find the refractive index of the water. So just apply Snell law, that the mu sin I is equal to constant. So mu 1 sin I1 is equal to mu 2 sin I2. So given mu 1 means mu z and the I1 is I, mu 2 is mu air, air is equal to 1 and I2 be the 90 degree. This is given. So mu g sin I is equal to 1 refractive index sin 90. So mu z would become 1 by sin I. So 1 by sin I, B would be your correct answers. Next one, JEE Main 2019. One plano-convex and another plano-concave lens of same radius of curvature is joined. The refractive index 1 is mu 1 and 2 is mu 2. You have to find the focal length. We just discussed in a chapter summary this concept, that lens maker formula 1 by f is equal to mu 1 minus 1 1 by r1 minus 1 by r2. Here for plano concave each one given. So r1 is infinity, r2 is minus r. Put this value 1 by f1 equal to mu 1 minus 1 divided by r. So f1 would be r by mu 1 minus 1. This is equation number 1. Second one, given 2 for mu 2 index. So here r1 is r and r2 is infinity. So by the lens maker formula 1 by f2 is equal to minus mu 2 minus 1 by r. So f2 would become minus of r by mu 2 minus 1. This is the equation number 2. By equation number 1 and 2, we just get the 1 by f equal to mu 1 minus 1 divided by r minus mu 2 minus 1 divided by r. So this would become the mu 1 minus mu 2 divided by r. So final, the focal length f would be the r by mu 1 minus mu 2. R by mu 1 minus mu 2, D would be your correct answer. Next, go ahead. This is coming in JEE Advanced 2013. In a Young's double slit experiment using a monochromatic light of wavelength lambda, you have to find the path difference, Derek's. Basically, for interference, I equal to I max cos square phi by 2. This is for the interference. And for the polarization, I equal to I naught cos square theta. Keep in mind two formula. I just write here for your understanding. This is for the polarization. So given I equal to I max by 2. So phase difference that would be the 2n minus 1 into pi by 2, odd multiple of pi by 2. So path difference would be 2 pi by lambda into twice pi by lambda into phase difference. So would be phase difference equal to 2 pi by lambda into path difference. So path difference equal to reverse, that the lambda by 2 pi into the phase difference. So path difference would become that the lambda by 4, 3 lambda by 4 dot dot 2n plus 1 odd multiple of lambda by 4. B would be our correct answers. 2n plus 1 lambda by 4, 2n plus 1 lambda by 4. B would be our correct answers. Next, coming in JEE Main 2016, the interference pattern is obtained with two coherent light source of intensity ratio n. You have to find the I max minus I mean by I max plus I mean. So here that the intensity ratio I2 by I1 is given n. So I2 would be the n of I1. So you have to find the I max minus I mean divided by I max plus I mean would be equal to, just put this value, root I2 plus I1 whole square minus root I2 minus I1 whole square divided by root I1 plus root I2 whole square plus root I2 minus root I1 whole square. Just calculate, you just get root I2 by I1 plus 1 whole square minus root I2 I1 minus 1 whole square, root I2 I1 plus 1 whole square plus root I2 I1 minus 1 whole square. You just get, put this value. So root n plus 1 whole square minus root n minus 1 whole square. So it will become root n plus 1 whole square plus root n minus 1 whole square. So it would become 2 root n, just a plus b whole square minus a minus b whole square. And basically this is the 2 into a square plus b square. So another one, this is the 4ab. This use this formula 2 root n by n plus 1. So our answer would be the B, 2 root n by n plus 1. Go ahead. Our next recent question, NEET 2024. A light ray entered through a light angled prism at point P at an incident 30 degree as shown in the figure. You have to find the refractive index of the prism. So you have to find here the mu. So here given, you just do in this theory that A is R1 plus R2 and the R2 is 90 minus R1. So just apply here the Snell law, sine 30 degree is equal to mu sine R1. So for AB surface, that the sine R1 is equal to 1 by 2 mu. Sine R1 equal to 1 by 2 mu. Another one is the AC interface, this one. For you just apply here the Snell law, mu sine R2 equal to 1 refractive index of AR, 1 sine 90 degree. Just calculate here. So sine R2 means, so here the sine R2 is 1 by mu. So this is the sine 90 minus R1. This is the 1 by mu. So this would become the cos R1 is 1 by mu. So you just know the sine square R1 plus cos square r1 is equal to 1, just calculate 1 by 2 mu whole square plus 1 by mu whole square is equal to 1. So 1 by 4 mu square plus 1 by mu square is equal to 1. You just calculate mu would be root 5 by 2. So B would be your correct answer, so root 5 by 2. Go ahead our next switched lecture in your homework session. So we just cover here the 5 important problems for a better concept and understanding, and I usually give you more better practice understanding and the concept. Another 5 important questions. Just pause this video and take a screenshot quickly. So I think you take a screenshot of these 5 problems. So we now cover here in optics topic the 10 important questions coming in NEET, JEE Main and Advanced, and I think after solving 10 important questions, you just go through all over the questions the coming optics section, and we just cover here the chapter summary of optics, and last the contact session. Solve this homework, and if anyone need my YouTube lecture file, just mail without no hesitation, without cash or injures 195@gmail.com. So last but not the least, thank you very much and stay well and happy. Have a good day. Thank